Hi. Today I'm going to explain my recent open source project that I worked on. Um, I view it as a project. It took me a couple months overall to complete, but it actually was just a what's called a cleanup ticket or a bug that the Google Chromium guys had flagged, and I volunteered to work on, and they were cool with me getting in there and doing the heavy lifting for the cleanup item. So what I have here right now are just a smattering of some of the files I was using. Like, I always have a project file that I have. Um, and like, here's a Perl file I was using right here. And to jump into it, the the big thing that I was working on was a reorganization of the classes for the network stacks log or logging code. So, um, from the end user's perspective, which is basically a person uh, working on the Chromium code base, they're going to want to, when they do their projects and stuff, they're going to want a way to log what's happening on the network stack, and the network logging code is for that. And one thing that happened was the the network log code actually got its own folder in the code base, and because of the growth of the code base, the inner classes for the netlog code or the netlog class could actually become um, their own classes and be put into their own headers and associated CC files. And this is something you want to do just as a matter of organization. Number one, organization. Um, you don't want to have God code files where the file gets extremely large and you have one class doing a lot of different things. You do want to keep things separated and modular, and of course you want to keep it separated and modular in accordance or in um, direct direct correlation with the size of the code base, I guess you could say. Of course, it makes sense to have things be in one file if you only need one file. If things are bigger and then the code is growing, then you want to think about splitting up the code. Um, so the the first thing I'm going to get into and talk about is um, compilation units. So I have some notes on my screen. Um, the 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 big thing to consider or be aware of when you're producing producing programs or applications is that the the program is this really big chunk of data that is basically instructions for the processor to process and bring about a whole bunch of behavior for the end user. And so, Chrome is this really big behemoth of an application that does a lot of really good stuff. I'm a big fan of Chrome. And of course, it's a web browser application. And the way for this big chunk, this big boulder known as the Chrome application, to get worked on and maintained and have extra pieces put into it is called separate compilation. So all the different pieces that go into it um, can be compiled separately, and this is a major pillar of compilation across, I believe, all programming languages, or at least the the main ones that everybody's aware of, like Java and C++ and C. Um, you you want to be able to have smaller modules for your pieces that go into a larger application, and sometimes these are called library components in C and C++. They are they're basically just that, library components. Um, and of course, one aspect of the library components is that they can have what are called unresolved references, so that parts of the code that call for a reference, whether it be a bit of data or a function to call, um, can be unresolved. They can still be up in the air to how they're defined, and when they are um, linked together and then pushed to an executable, those references do want to be resolved. So, this library module here, this separate compilation unit, can have A and B unresolved references. Let's put a question mark next to them. And let's say it needs to link up with this unit over here, in order for these references to become resolved and for the final executable to be happy and be allowed to be compiled into an executable by the compiler. So that's the groundwork, or that's the basis upon which um, a lot of the rules for developing code and developing programs and software come out of. And I'll get into it as we move along here. And what else can I say? The next thing, or actually, here, I'll just move. One second. Oh, my layer is locked. Alright, so that's going to go away. The the okay, so given that that explanation I just provided you, one thing that C++ files will do is they'll have a header file. They'll have a header file which will be interface, mainly a description of an interface, and there will also be a definition. There'll be a definition of whatever classes are in the header. and in the C++ or C file, there'll be a lot of method definitions. So the interfaces that are declared and made in a short form, and the header file, those methods, those functions that are called off classes, um, are actually going to be defined in the C file or the C++ file. And um, the big thing to be aware of is um, the method definitions are, they get pretty big. The idea is to have the header be lightweight, and then the C++ uh, compilation unit file is lighter weight, or I mean is a lot heavier weight. And the reason why is that this C++ file is actually what gets compiled into what is called a translation unit, or like I was saying earlier, a compilation unit. So this guy becomes one of the library modules, um, and it can have the unresolved references in it, and it'll have a lot of what um, the headers that it has included in it. It'll have a lot of that header data in itself. So this C file, is going to have header includes abundantly, and these will all be what are called preprocessed, um, and laid out in the translation unit. Whereas in the C file itself, there's just a include declaration that says include, header foo, or header omega, or header delta, or whatever cool name you want for your headers. So that leads the way um, to the matter of how do you go about managing your header includes in a large and growing code base. So you might have different C files that have their different H includes, their different header includes, right? And this header may actually, and all, more times than not, basically all the time, the larger the code base is, will have its own header includes. And the big hiccup with developments that can occur is when you go into this file and you want to do some work on it. I'm going to make a hammer here. So when you go into this file and you want to chink away at it and manipulate it, you may not need. You may find that you don't need this header file, right? Well, you want to take it out because you don't want to have unnecessary weight in the compilation unit or translation unit that is outputted by this C file. So you, of course, delete in your text editor the designation of including this header, because as you're working on it on your C file, you find you don't need it. Well, if the person before you wasn't careful with how they developed their code, they may have hidden an include dependency uh, and not appropriately um, included what they were actually using in this file. So H star here, um, it should have actually been written into this file directly and not hidden by this other header include. Um, and that's the idea is for whatever um, headers you are actually using in this C file, you want to write out in your includes that you're using them. You don't want to have the situation where um, a header that is actually used in the compilation unit um, is being hidden by a header that you're using already, because it'll compile, but it is a deterrent to healthy development and growth for that compilation unit and the development of that file as it changes over time. So um, so we don't want to have our include hiding. We don't want to have this be relied upon, even though that actually exists. So we'll still leave it there. So even though this header, um, even though this header, which right now let's say is actually being used and is supposed to be included in the compilation unit, even though this header includes this guy, we want to still write out what we're using in the file. Um, so one thing that was happening a lot with the netlog code was we have the netlog class, right? And it has a netlog H file and a netlog CC file. And this guy being included throughout the code base, which does happen a lot, was leading to a lot of hiding of headers that this guy was including. So this netlog header has an abundance of headers it includes. It's a pretty heavy file, and as it was being included across the code base where it was needed, which was a lot, there were include hides occurring where um, uh, compilation unit delta was including this guy and not um, writing out what it was using actually, because it was it was able to compile by way of actually depending on some of the headers that netlog H was including itself. And yeah, so that was one big benefit that was communicated to me by the Google guys, was that the work I was doing um, to extract the netlog inner classes and do their own classes would also be a way to clean up a lot of the instances of um, netlog h um, doing include hiding, because by way of changing the code base and appropriately doing includes and forwarding off of the new netlog classes, the netlog header would actually be removed a bunch. So that removing would bring forth the include hide dependencies, make the compiler basically call out, hey, I'm not finding the headers that were hidden by netlog h, and I can't compile this unit now. And that was encountered a lot during my development and was fixed. So now I would be able to go into these files and add the includes that were being used in the file, as is desired for healthy development. I'm making sure that the code bases include what you use, quote unquote, clean. And that that is getting into the basis of the work I was doing. Um, One thing to do that'll be nice to look a little bit at the code here. Let's see if I can get rid of the. It's still doing it. All right, sorry. There's highlighting of net all over the place, but just these are all the includes that are currently in the netlog H code. It's a lot of includes, and like it's including netlog capture mode. Okay, that's not many. That's included itself. So yeah. Just to get an idea of the amount of includes here. And well, yeah, one thing I can do is explain. Does it? Yeah, it's still there. Okay, so the classes that were extracted out of netlog class were netlog source, netlog entry, and netlog with source. I think there's a little bit of it'll be appropriate to explain how this works. These work somewhat. Netlog with source is a netlog object that already has the source, which is this specified. The source is the 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 source of where the netlog event that's being recorded, that's being logged, happened. And entry is an event that is logged. So yeah, um, I didn't study the netlog code itself that much. I was able to really focus on the layer I was put in charge of, and it turns out that I didn't need to actually know how these guys work that much. And the Google um, guys I was corresponding with, I let them know what I was going to do, and they were saying, "Yeah, go for it." So, you know, those guys that did know the net code very well, probably saw parts on their end where they were, you know, copacetic with how everything was going to happen, and given their much deeper knowledge of the netlog code in itself and how it works, and given the work I was doing, they said go for it. So I had the green light, and I then set about, you know, coming up with a process to um, to uh, write. I wrote the new CCH files for these three guys, and um, all of the instances where across the code base that were referencing these entities were changed to reference these entities now as classes and not inner classes. So whereas the entity was being referenced as um, netlog entry, for example, and the two colons representing the inner class, it was changed to netlog entry. Um, that is that. So all the names, the naming of all of these inner classes were changed to the new class, class names across the code base, and it was like several hundred files that needed to be changed. And that was easy. That was the first step of my process. So I had a Perl script that I wrote called change naming, and it went in and basically did this step many times. Um, the steps afterward, which took the brunt of the development work, were to appropriately add the includes of the new headers to where the corresponding classes were in the files that had them. So adding the includes for the headers, or um, adding of adding of the forwarding of these classes, not including but forwarding. So I'm going to write include or forward. Um, so I'll get into forwarding now. So in Chromium, on the Chromium open source project, the powers that be have deemed that forwarding is favored, is to be done. Um, and what, may you ask, is forwarding? Um, so in C++, you sometimes only need to know the name of a class, and you don't need to know the definition of the class. You could have a whole translation unit that only needs to know a class's name. It doesn't need to know the definition, which the include would have. In that case, you could forward. And the way that this works is you only need to know the class name, where um, the rest of the code doesn't need the definition. The rest of the code only references or has pointers to whatever the class is that's being forwarded. So you could say at the top of your CC file, which becomes the translation unit, you could say class X, and the rest of the file. When you're referring to X, if you are only using a pointer to X, or using a reference to X, which basically is a pointer, like this, const X ampersand const X reference, then you only need to do the forwarding. This is a boost in one main way, and that is compilation dependency reduction. So once again, like I was saying before, Chromium is this giant product, and there's many translation units that have a lot of includes going on, and the more you can rely upon just forwarding, the better, because if you did have to include X as opposed to just forward it, then anytime anything changed to the X include, or any of the includes that the X include was including, then you would have to recompile the entire translation unit, and that leads to a big drag on compilation time if you aren't forwarding where possible. Chromium's decree, or Google's decree for open source projects that it has in general, is to not do forwarding because it makes the code a little bit more complex and harder to discern. But for the Chromium open source project, they do decree to forward wherever you can, because of it being Chromium being a giant program, and they say yes, please do forward, because you will be saving everyone a lot of time by reducing compilation dependencies and making everything compile less and save time that way. So what this means is that for these new classes being extracted out of the netlog class, they would all have to have appropriate including and appropriate forwarding, or appropriate including or appropriate forwarding, based upon how the classes are being used in the CC files and H files. So my Perl scripting, my chosen method of manipulating the C++ code base, would need to basically read into all the files it was changing, and have some, awareness of of here's a situation where I will include, and here's a situation where I will forward, and manipulate the code base accordingly. Um, for the amount of files that were being needing to be changed, for all of the client instances and processes, or client instances occurring across the code base for these classes, um, and how the including forwarding needed to be done. It was a giant task. Definitely needed to be done with automated scripting, um, at least to start. I mean, to go in there and manually change everything would have been a huge headache. Um, and I thought about it. I could have, if I were somebody that knew the rules of the code base well enough. You know what? I think it may have been more efficient to actually just go in there and manually change, maybe, um, because the scripting actually turned out to be a pretty big task itself. But since I didn't, know all of the rules for forwarding and including, and would be discovering them throughout my project as I worked on the code base and kind of saw what was what, I thought, you know what, I have to script, because with scripting, I will be able to change the script in accordance with the newly discovered rules I was finding for how to manipulate. Yeah, so that's that. Let me think if there's anything else. I think I've explained it well enough. I have a little spot here for my next part. So I will get into a description of my process. So there were layers for the scripting where I would have the script, one layer of my scripting run, and then I had layers further that would run on top of what was done before. So my first um, my first layer actually wasn't a script at all. It was just netlog file changes. So I'll just say netlog files. Um, change naming, PL Perl. So that was that name changing of the inner class uh, data type, references throughout the code base, um, yeah, just the data type references. Yeah. Um, and then add includes Perl. Remove includes add forwarding Perl. post remove add includes. .pl. And then add or forward.pl. And um, this guy changed naming. I think changed like 190 files. Um, add includes changed like 400 files or something like that because netlog with source actually wasn't an inner class. It was a class in the same CC file as the netlog class. And so there was a ton of netlog with source references or names across the code base. And since netlog with source would no longer be included from netlog.h and included from netlog with source.h, then the adding of all those includes was done. Then, so I had change naming be done as a way to say, okay, I want to change all my names first and then have my other code hook into the new names. So my rule was do the changing of the names first, then have other layers hook into the new names. So I did that. Add includes. The idea was, for coming up with a logic for including or forwarding or whatever, I'm going to do just a blank adding of includes across the code base. I don't know if it should be forwarded or if it shouldn't be. I'm just going to add includes everywhere that there is a name for whatever data type I want to add the include for. 1 second. I'm going to grab a drink of water. Wow, okay. I'm at 42 minutes right now. Looks like this will be a long one, but this was a big project, and this is my first time presenting on it, and maybe I can get it all done in one take. So, add includes. One important thing for this one was the beginning of figuring out the minutia of logic for how to go about doing includes. Like, if we have a CC file and it's a tandem H file, if the H file includes omega, then and the C is always including the A. The CC always includes the H as a convention in the Chromium code. So if you have a CC with a certain name like Zulu.cc, then Zulu.h will always be included by Zulu.cc. So one of the rules that was like the main rule for how to add includes was if your CC, if your CC's H partner file is already including one of the includes that you're thinking of adding in it, don't include it because it is okay to not include, and it's more efficient and beneficial to code cleanliness to only include in the header. That's the preferred way for all the developers. They all agree upon that, and it makes sense. The header file is gonna, if it needs to do an include of whatever class you need to include, it'll make this code more clean and more thrifty and less cluttered if you don't include it again here if it's being used. And you're guaranteed that you're going to have it because the CC always includes the H. So, that was like the main rule for doing the add includes. And that type of thing, just to add in a little development skill spritzer. Um, when you're doing this stuff, it's those little rules that you come up with first that allow you to jump into the more complicated, heavier, or harder to do tasks. So that add include basic rule, you know, was encountered from day one, but figuring out how to do that first is the door to doing the harder stuff. Um, so that's the add include. So I did a blanket, just don't care if I should forward or include, just include everywhere. That's the add includes. Remove includes add forwarding says, okay, now I'm going to go to all the places where I added my includes and remove includes where appropriate and add forwarding. That was that layer. The next layer, which I was thinking I would be done, you know, with level D here. But if you think about it, oh man, we're removing includes. If we're removing includes, then that means we might have to be adding includes in other places. The basic idea there was if you're in your HCC basic pair, if you removed uh, an include from a header file and added a forward F, well, the CC no longer has the include that it had by way of including the H, right? So what that means is you're going to have to add the include to the CC. So there was a whole nother layer here of what I called post remove add includes .pl. And then this last one was add or forward. It turns out that removing the netlog H code, there were two forwards and one include that were the main include hidden entities or forward hidden entities, and that they were base namespace, value class, and base dictionary value, and the include that was a very largely hidden include was netlog capture mode class. So this script was basically a way to go through the code base and identify all of those include hide landmines, the ones that I was seeing happening a lot, and I just went through the code and said, hey, go through all the files that I've touched where I removed netlog H header, and if base value or base dictionary value isn't forwarded, forward it, and if netlog capture mode class isn't included, include it. So I had this script for removing all the biggest include hide landmine culprits across the code base, and this script actually worked on it changed about 40 or so files. So on top of the landmines that I removed by way of finding them and compiling compilation errors, these guys, which I scripted, removed automatically like another 40 or so. And this was a lot of fun to see work, because just like the Google guys were saying, they were like, oh man, with the netlog netlog H file is this big bad guy for include hiding mishaps. And me running this script was felt really good because it was like, oh wow, automatically I just got rid of 40 instances that were these landmines waiting to blow up on a developer in some future project. You know, basically, I'm clearing the way for future developments where if a person's developing and they, you know, turned out to need to remove um, netlog H, um, well, it turns out that um, you know that it's going to be clean. It's going to be cleaned for them. Yeah, that felt pretty good. So enough about that. I'm gonna go ahead and get into explaining. We'll be looking at the Perl files a little bit, getting into the regex minutia, and getting into regex land talk. So let's look at the add includes.pl file first. Okay. Um, so this was a big function here, or subroutine, sub as they like to call, in Perl, called recurse files. It basically um, recurse through all the directories and the code base, and if the file was a CC or H file, then it's something I wanted to have my scripting look at and potentially change. Right here, I'm using the hour scoped variable. Um, I'm calling it G file path. This one was kind of cool because in C++ there isn't something like this, which is the ability to have a global variable be um, declared within a function. Like in C++ or C, you'd have to have it be done outside of the method or function, and then you could control it from that function or any other function. With this one, you could be scripting on the fly and write hour and not have to write it outside of the function, which it's a way to do it. It's a style, and like any styles, can lead to productivity and artfulness, if you will. So um, we got G file path, and then change file happens, and I'm detecting for the file path not being one of my no fly files. So I wasn't going to change any of the core netlog files. So, and recursing through and potentially changing files across the code base, if it was found to be one of my main netlog files, didn't even want to have my scripting for appropriately adding or forwarding touch those, because I manually change those myself. We got I like doing my file intaking or what have you with this method here. using dynamic scoping, which is a Perl thing, I am saying that the record separator is nothing. It's not set to anything, so that when I slurp, which was the term that I found online, when I slurp out of the file handle here, it'll ingest, or it'll stream over all of the data to my file variable, as opposed to piecemeal by default. It's new line, which is what happens when you don't dynamically scope your record separator like I did here. So, like, what else can I say? So change file. Get file header is a function that basically gets the file header content that goes with the file. If file is already file header, which it may be, then file header and file become the same thing, and it turns out that that effect was benign in the code manipulation, or scripting manipulation of the code. Maybe add include is a function that you pass in the file content, the file header content, a regex for the different types that I'm trying to detect and apply logic with, and the types where it's the inst regex. So I'm having a regex that says for these different types, like netlog with source, netlog entry, I'm having a regex for detecting instances, which are like constructor calls, or calling of methods off of those classes. So instances where I would need to essentially use include adding as opposed to forward adding. And I'm trying to think. I'm thinking in terms of somebody that might, be like, oh my god, what is all this stuff? This is it. This is the code for adding the includes across the board. The reason why I am assigning a variable to the result of maybe add include was, if include wasn't added for the CC file I was concerned with, for any of the types of includes to add, then I wasn't going to write back my changed content to the file because I hadn't changed it. And it turned out that making this change really sped up the processing of this script while it was executed across the thousands of files it was processing. Okay, so maybe add include. Here's the function. It's taking references to the file content, the file's header content, netlog type regex. So let's look at the netlog type regex. I'll put it up here. So netlog type regex was passed into this function as these guys. So netlog with source regex, netlog source regex, and netlog entry regex. These are what was passed into maybe add include, and are the netlog type regex parameter here. And if you look at these regex variables here, So QR is the making of the regex variable. And so, yeah, one thing to be aware of was I am saying the reason why I'm not just passing in a string of netlog entry is I want to only manipulate the data when netlog entry itself is detected. Nothing else around it that could indicate another um, symbolic reference across the code base, aka name. So if netlog entry, um, if there were another symbolic reference across the code base like netlog entry um, bar, if there were netlog entry bar, well, then my code would be thrown off by netlog entry bars and change um, netlog entry to what I want to change it to, um, or it would detect netlog entry bars and throw in an include of netlog entry.h when it wasn't actually a netlog entry that was in that file. So that actually happened with some instances. Like I believe it was netlog source. Yeah, netlog source. There was like some other uh, symbolic reference, aka name, that was like netlog source something or other. So I made sure to have my regex detect against the netlog source something or others in the code base by this um, defining here of the regex. The look ahead. Once we get to this mark and regexing through the code, the look ahead says don't match a word character right next to the e here. So I'm coming up with a way to really only add my includes when I want to add them. You know, like when I'm having maybe add include. So if find regex netlog type within the file ref. So when netlog source is found within um, the file I'm looking at, eventually after all these other rules that make it not happen, I'm going to add the the include that I need to add now because the netlog uh, type is its own class and has its own header file, and that's what I'm doing with this script. Um, Give me 1 second. Okay. Um, okay, I'll just read through the code as best I can here. So if we find netlog source regex, if we actually find netlog source without any other word characters adjacent to it and basically like white space adjacent to it, we've identified a netlog source um, reference in the code base. Actually, inside of the file ref, inside of the file's content that we are potentially adding an include to. Um, so once we found it, and we do not find um, the the forward um, of the netlog type, so we don't see a forwarding. Well, then we are given the green light to continue to progress toward potentially adding the include. I have a bit of code here for making sure. Yeah, this was done for this netlog parameters callback thing. Don't even worry about that. Okay, so just keep following along. There were a lot of little gotchas where I had to add in some extra code and work towards you know doing everything right and coming upon the approved code. Um, yeah, this is all stuff where it's hard for me to remember exactly what was going on. But one thing I'm identifying that I want to explain is the find regex function I have here, because a lot of the times um, you could just use the the normal way to determine if a text pattern, a regex, is within some data. And a good example of that is right over here. Okay, so diff diff data is a chunk of data, and we're looking for a match of minus sign, hash symbol, include, um, white space, escape s, white space, quotation mark, net, actual slash log, actual slash net underscore log, escape the period to indicate an actual period, h, quotation mark. So we're looking for include netlog h in the diff data bit of text content. That is what my find regex is doing here. So netlog type regex would be here, and file ref would be here. The reason why I'm using find regex is because I don't want to have the match occur given certain special scenarios. So let me go to my find regex code so I can explain. Here's my find regex code. Um, the main benefit is that it is going to not match for when what is being regexed for is a comment in the code. So I don't want to add includes or do forwarding or anything if what I'm detecting for adding the includes or forwards is a part of a comment. Um, it would be unnecessary and add bloat to the code, and upon review by the Google guys, it would be called out. And given manipulating hundreds of files, you know, I didn't even go look for it. I just assumed that I would want to code something like this. And actually, I have had instances in the past where I had logic happen based off of what was being based off of regexing for stuff in comments, and I've seen it happen before. So I just came up with this handy dandy function to not match what would be matched if not in comments. And it's the same for quotation marks. Um, net underscore log dot h, if it's in quotation marks like it is in include quotation netlog dot h quotation, um, netlog could be it that could be a data type that is calling a function, or it could be a reference calling a function that would call for an include to be added. So I didn't want to have my include add behavior, which I just explained right there, be based off of a false positive of calling a function off of a potential netlog data type reference called net underscore log with the dot, because that was my way to determine if the reference was actually being called, was looking for the dot, um, and netlog.h in the quotation marks was throwing that off. So I had to detect for net. I had to not have my detection occur for stuff inside quotation marks. Okay, so that's that. Um, what else? Another thing is, oh god, this is Perl code, and it looks really nice and funky and pearly. Um, so I don't know. In Perl, uh, the function parameters aren't written out. There's just this underscore at symbol to indicate array, and the way that you access variables for underscore at, which is the function implicit function parameter array, is to do dollar sign underscore and then the index of what you want to access. Um, so RegEx is always going to be the first one. uh, what this code does is it um, it is iterating through the rest of the parameter variables after the first one, and all those parameter variables are the contents of files, whether they be the CC file or the header file. And there's times where it was just one file being regex through, or a couple. And in the cases, I wanted to have a function that could work with throwing in one file being regex through or several. So this function does that. Yeah, just looking at the code here to explain, because this is me practicing verbalizing how all this stuff works. File ref is the contents of the file, and what I'm doing is matching. I'm looking for the beginning of comments // and then any character 0 or more times, and then a new line. And I want to be lazy with the characters to the next new line, because if I didn't do this quotation mark after the any character dot symbol and the asterisk, then when I had a comment at line X, it would basically do, okay, I'm going to be as greedy as I can in matching something, and it would match to the last new line and the text being matched against. This lazy quantifier, this question mark, says match as quickly as possible. So it's matching from the comments started to the end of the line, just for one line. This guy does the same thing. Just match from quotation mark as shortly as possible with some stuff inside to the next quotation mark. And the pipe symbol here is the alternator and regex Perl style. I don't know about other regexes, but Perl, it's the alternator. It means match this or the regex, which in my find regex function here, it's the netlog type regex. The way that I am not matching the regex when it's inside quotation marks or after comments is I'm matching the comments and the quotations and moving the file ref contents current position marker past that data, so that the regex can't match against whatever the pattern is inside quotations or after comments. The way that works is there is a priority to match this stuff inside of the alternator groups at the beginning of the regex, as opposed to the ones that come after. So this is always going to match before the quotation mark alternation group, which will always, both of these guys will always match before the regex group can possibly match. So I am essentially coming up with a way to, as I've said before, not have the regex match for text patterns that would match when those text patterns follow comments or are in quotation marks. And if you're new to regexing stuff and you're really digging me explain this, one thing to be concerned with is that the G right here means as you're matching against whatever you're matching against, move the marker of the text. So imagine this is all the text here that we're matching against. The G means, okay, when we got a match and we match it for the first time here, keep the marker at the beginning of what is remaining to be matched and the content being matched against. Don't have it go to the beginning again. This G I use a lot in my code. It's my style of using regex. You could do it different ways too, but this is my way of doing it, and it mainly works well with when you have all the content that you're regexing against be all in one big blob. Okay, the X means white space and new lines within the regex are to be not matched against, and if you want to indicate a space and match a space, then actually write out \s. You know, one thing to consider is that, you know, like this little segment here, if I didn't have the X qualifier for my regex following it, this space would need to be matched against. Now it's just a space that is being used not as a part of the regex definition, but as a part of human readability. Okay. See if I can think of any other stuff here. I have some notes on what to talk about. And what time are we at? Hour 18. I think I'll talk for another 20 minutes. Just keep it going. There's a lot here, and I'm almost through it. We'll look at some more of the Perl code. I want to look at remove includes add forwarding. So I have a remove add function. Um, remove add is being called upon the CC and potentially associated header. And yeah, one thing too was um, so there's a lot of files where it's like netlog, where it's netlog cc, and it has a nice buddy and its associated h file. Well, it turns out that there's a lot of unit tests, and if there were netlog um, unit test cc across the codebase, these unit test cc files sometimes had includes done in the same fashion, where the associated header was being included in the netlog unit test cc file. Other times, that unit test didn't have the include of the associated header file, and I had to have logic in my get header or don't get header scripting to adjust. So basically, I'm going to bring that up actually now. My get file header, where was that? Yeah, get file header is yeah, mine's in lib. There we go. Okay. This is a PM file for Perl module, and I have my get file header subroutine. So I'm saying file header ref, it's a reference as opposed to a copy. And I don't know Perl well enough, but I think I may have been not needing to do the ref part, but I did it just to be safe, and that's how it ended up. Yeah, see here, if file path, which I'm trying to get the header for, matches beginning of string, any characters one or more times, underscore unit test, actual dot in CC. The what's in this capturing group inside the parentheses is what becomes the one variable here. And I'm saying if the file path matches a unit test, and there actually is an associated header, then I'm saying I have this other function, check unit test has include, which is this one. And I'm actually going into I'm opening up the unit test I'm opening up the unit test header and seeing if it is doing the include of the paired header or not. And if it is, then the logic for that I explained of not including if the header has it would be used. So, gosh, for such a big code base, it's not as simple as you would like to code this stuff, but hey, why does it matter? Just get better at doing this scripting stuff and be able to take on the challenge of writing scripting that can handle the nuances of a large code base. Okay, so yeah, like one thing, gosh, there's just so much stuff that really needed to be paid attention to to change everything the way that would be approved and the right way. So netlog type parens regex is a what it is basically detecting for the different functions across the code base that return uh, a netlog with source or netlog type. And I'm basically checking for a call off of the that method that returns a netlog or netlog with source type, so that if there is a call, then I'm returning. Why? Because I don't need to add forwarding and work my way to where I would add forward down here, because there actually is a need for the include. Um, and once I get past that point, for the data I'm trying to manipulate and remove, include, add forward, I actually do um, substitute the include to remove, detected by the include to remove regex here, with nothing. So I remove the include. Um, if not, check for non override refs. Yes. So this was another big got you with the behavior and complexity of the scripting. Um, so I am trying to determine here if I even need to forward after removing the include. How is this so? It's because if the file that I'm changing has um, has a reference to my data types I'm concerned with, but that is occurring through um, uh, methods that are override methods. And so a good way to show this is by example. Okay, so, and I have my page set up here for the presentation. Create transport client socket method here. It has an address list reference. It has a unique pointer of socket performance watcher type as a parameter. It is also an override function. It is a function that is a polymorphic function that is overriding the base class's method declared in the base class of fuzz socket factory class, which is client socket factory. So client socket factory has the base method create transport client socket, and we're overriding it here. We are guaranteed to have address list, socket performance watcher, netlog pointer, and netlog source reference all be forwarded, or perhaps even included, in the client socket factory file. So we don't need to forward or include, or forward in all these cases, these data types in this file. We don't need to do it. It isn't done here. You don't see any forwarding of address list up here. Why? Because address list isn't needed as an include. It's not being called off of, or you're not calling the method for address list and needing this definition anywhere in this file. And you don't need to forward it either, because you're being guaranteed by way of this being an override function, that address list is forwarded by the base class. Thus, as a matter of code cleanliness and a uh, an attempt to not bloat code, we're not going to write the forwarding again in this file. So that's where I have a function called check for non-override refs. It is looking for refs that are not override and returning true if there are non-override refs. If the file I'm looking at has data type refs that aren't override, right? Then I want to add the forward. But if that is not the case, which this block here detects for, I'm going to return. I don't need to add forwarding, and I already removed my include, and I am leaving the code in a state that is what is desired by the Google guys, by software developers and engineers. Okay, and I make my way down to this function here, add forward. I'm adding the forward. Yeah, there's a lot of stuff here. Gosh, I won't even get into it. Oh God, yeah. Look at it. Look at this. Look at this beautiful, huge function here, which I use to detect uh, non-override refs. This is the RegEx, and this is the whole check for non-override refs function. I actually was, yeah, just to explain it quick, I was um, slicing up the file content into every method block, um, and checking for not override refs. There's a lot there. I I was using dynamic regexes indicated by the two question marks. I needed to use dynamic regexes. It was a lot of fun, and there's a lot there. One thing I suggest, if you're really into regexes, go and buy Mastering Regular Expressions. Very fun text to read, if you're so inclined. I found the author to be a good author for the software text. Um, he explains things very easily. A little bit, he over explains, but he makes it fun, and who cares? He's just getting across concepts and having fun with it. So, Mastering Regular Expressions, he explains how all this. He has a whole chapter on the Perl RegEx stuff. It's all good. Before I finish, I want to explain one last section. And give me 1 second. I'm gonna get a drink of water here. Okay. Um, I did want to double check, manually check all my files I touched. Even though I had all this scripting, change the files. I really wanted to make sure that everything was hunky dory, manually. And, you know, it took me like 12 hours to do. It was a journey to do it, but I don't want my thought was I don't want to leave this code in any worse state, any any iota of possibly being worse state than it was before I touched it. So did the manual check of everything. The stuff I was mindful of while I was doing it was, yes, I've gotten the code to a state where it compiles with my new uh, uh, code um, organization, where there's the new classes and the new files that go with them. I've gotten it to compile, but let me make sure that I have appropriately done my includes and forwarding, because I don't want to have any forward hiding or include hiding on my part, based off the code that I was doing. So, I just had that inside my head the entire time. Every time I checked every file, I went through and made sure that um, any place where I removed code, uh, or no, yeah, any place I removed code where I maybe didn't actually add the include that I needed to, and things compiled because of include hiding, I made sure that the behavior of my scripting not doing the include was correct. And, um, well, you know, it got submitted for review. There was a lot of other eyes that reviewed my work too, and it wasn't found that anybody found anything like that. And I did my own manual checking, and by the end of doing all of this work on this project, I felt like a include forward, you know, genius. Um, so I feel strongly that it was done right. I didn't add any landmines to the code, which is really what you want to be aware of when you're developing. You want to improve the code base. You don't want to hinder it as a result of your contribution. So, um, that is it. Thanks for watching, and have a good night.